Hello everyone, welcome to this new video. So in this today's video, we'll be solving the question number following a pattern. And this is a medium level question and it's the problem of the day on Geeks for Geeks. So the company tags of these questions are Amazon, Goldman Sachs and Google. And the topic tags are strings and data structures. And yes, it is a medium level question. Like it takes some time to frame the intuition and then build up the logic and then code it up. But once it's once the perfect logic or the perfect observation is identified, then it's pretty simple. The code can be written just using some basic while loops and replacement. That's it. So let us go through the question now. So given a pattern containing only i's and d's, I stands for increasing, D stands for decreasing, devise an algorithm to print the minimum number following that pattern. Digits from 1 to 9 and digits can't repeat. Alright, these are some of the two important points like that need to be noted. So digits must be only from 1 to 9 and digits cannot be repeated. So these are some base sample examples that are given. We'll just look into it later. And the expected time complexity is O of n, space complexity is O of 1. Alright, and we are following these constraints and we are going through the most optimal solution possible. And the length of this string can go up to 8 and starting from 1. So this is a very small constraint, isn't it? So it's just like the length of string can be from 1, 2, 3, 4, 5, 6, 7, 8. Just these possibilities. That's it. And because this is very evident, because the digits can only be from 1 to 9. Once you plan of once you're trying to make a string of more than 8 or something like 9 or 10, you need to use some more digits. That's not possible. So that is the main reason the length of the string is pretty much confined to the 8. So now let us go through the examples. Now going through the sample test cases. So this is the example 1. The example 1 sequence is D. So this is the example. So the sequence that has been given is D. Now why is the output 21? Why is the output 21? The reason being in 21, alright, in 21 we see that from when we go from 2 to 1, there is a decrease, right? There's a decrease. So that is the reason this is the answer. This is the required answer. But you might be thinking, why only 21? Even in 32 we find this thing. Even in 43 we find this thing. Even in 41 we find this thing. Like when you go from 4 to 1, your value has been decreased, right? From 4 to 1 that it has been decreased. So D is following. But out of all the possibilities, 21 is the minimum most value, right? So that is the reason this particular 21 is the answer. So you might be thinking, then why 1 0? Okay, even 1 0 is a case, right? Because from 1 we are decreasing to 0, so there is a decrease in the value. But it has been clearly mentioned in the question that the digits, alright, the digits 1 to 9 are from 1 to 9. So you cannot take 0, alright, you cannot take 0. So the minimum most value that you can take is 1. The minimum most value you can take is 1. Now because it's been clearly mentioned, the sequence is only D. So you need to write some number to the left of 1 so that it becomes it is decreased. So that is the reason we are putting 2. Alright, I hope you people understood. So it can have also 3 1 is a possibility, 4 1 is a possibility, 5 1 is a possibility. Hell lot of possibilities are there, but we need to put out the minimum most value. All right, I hope you people understood why 21 is the answer for this particular question. Now coming to the second question, this is a very good example again. I D D D. All right, now we need to place some numbers in between. All right, so that from when you go from 0th number, or instead of writing 0th, I'll just use yellowing. From this number to this number there is an increase. From this to this there is an increase. All right, there is an increase. And from this to this there is a decrease. From this number to this number there is a decrease. And from this number to this number there is a decrease. All right, there is even a white blank here. So you need to place the numbers in such a fashion. All right, now let us put these values. So I say the values are 1 2 6 5 4 3. So is the pattern being followed? Yes. From 1 to 2 there is an increase. From 2 to 6 there is an increase. From 6 to 5 there is a decrease. From 5 to 4 there is a decrease. From 4 to 3 there is a decrease. And 1 2 6 5 4 3 actually follows the required pattern and also the minimum possible value. It's a minimum possible value. There is no other value apart from 126543 that's minimum than this, and it follows the pattern. There is no other value. All right, so this is the most optimal minimum value that's possible and following this particular pattern, that IIDDD. So there is an increase at the points where increase is there, and there is a decrease at the points where decrease is there. All right, so this is the main important thing that need to be understood. So that is the reason 126543 is the answer. I hope you people understood. We are just understanding why that particular thing is the output. We are not framing the approach. Now we'll start framing the approach. All right, now we'll start framing the approach. The very first point that we need to make a note of is digits are unique. Okay, digits must be unique. So you cannot use the same digit once again in your particular sequence or string. All right, so you cannot use 1 1, you cannot use 2 2, or you cannot use 2 3 2. You cannot use, for example, if I say the sequence that I've given is di. All right, and now if you are like, I'll be putting 2 1 and 2, because from 2 to 1 there is a decrease, from 1 to 2 there is an increase. You might say this is a possibility. No, I'm using 2 for twice. This is not feasible. This is not allowed. So you must make a note of this particular point, that digits must be unique. All right, so that's the first point. And second point is, at increasing things, wherever I is mentioned, we need to increase. Wherever d is mentioned, we need to decrease. Okay, that's a normal point. But the first point, digits must be unique. Second point is, you need to increase, okay, or I would say you need to increase such that it can compensate the decrease. All right, increase is such a manner that it can compensate the decrease. So what do I mean by that? Now let us take this particular example itself. Okay, we have I D D D. This is the second point, is the most wonderful logic. Once you find this, you have almost solved the question. All right, now we have seen that I have placed 1 year, right? I have placed 1 year. I have placed 2 year, and 2, and I have placed 6 year. I have placed directly 6 here. Why did I place 6 at the very first thing? That must be the question, right? That must be the question that must be coming. Why did I place 6 at the very first instance? Let us assume there are no D's here, okay? Or I'll be writing a particular thing here, IID. Okay, let us assume there is only IID with us, alright? IID with us. In this case, I'll be writing the answer is 1, 2, and 3, and in this case, the answer is 4, 3. Now, why is my answer 1, 2, 4, 3? How did I come to this conclusion that my answer is 1, 2, 4, 3? See, whenever I encounter this particular D, alright, whenever I encounter this particular D, I see that I need to decrease my value, alright, I need to decrease my value. Now from increase, whenever I see I need to see that I need to analyze the, I need to increase the value, right? Whenever I find I need to increase the value. So now let us assume I've increased the value from 2 to 3. Alright, and I've written the sequence as 1, 2, 3. And now when I find a D, I need to decrease. So when I decrease from 3, what are the other possibilities? Only 2 is there or 1 is there. So even if I place 1 or even if I place 2, both of these cases, I am violating the very first rule. That is, unique digits are not being maintained. Isn't it? We need to maintain the unique digits. So I cannot have 1 or 2 here. Alright. So you cannot have 1 or 2. And if you do not want 1 or 2, you must not have 3 here. Alright, because there is a 3 here, you are looking out for 1 and 2. If there is no 3 here, if it would have been 4, then you could have the options like 3, 1, 2, and you can choose 3, and the answer would be 1, 2, 4, 3. Happily, this is a most, like all the digits in this are unique, and it satisfies the first condition. It is also satisfying the pattern that has been given. Everything is being satisfied, and this is a very good answer, and the minimum most value. It's also alright. So this is the observation, that you cannot take a value that is not compensating the further decreases. Alright, you need to make sure the pattern is being followed as well as the uniqueness is being followed. If I do not take 4 here and if I take 3 here, I have to go with 1 or 2 in this particular column, and that violates the very first rule. Alright, so that is the reason I cannot go with 3, rather I'll be going with 4. Once I'll be going with 4 here. Alright, let us assume I'm putting the 4 here. Alright, so it must be decreased now with the next number. So I have the possibilities as 3, 1, 2. 1 I have already used, 2 I have already used, but 3 I haven't used. So I'll be putting 3 here, and this is the minimum most possible answer. I hope you people understand. Similarly, in this case as well, we see that. Similarly, in this case, we have I, D, D, D. So now let us assume I'm putting 3 here. Alright, I'm putting 3 here. Now when I encounter a D next to the I must decrease the value from 3. Now what are the available options that I have to for decreasing from 3? Either I can place 1 or 2, but both of these are already been used. Alright, so I cannot use these two. So if I do not want to use these particular two values, then I must not place 3 at this point. So I must look out for some other number that I could place so that I can successfully accomplish this D. Alright, so for that reason I'll not be putting 3 here. Rather, I'll be putting a 4. Let us assume I'm putting a 4. And now I can keep this value because there is a decrease here. So now from 4, I can decrease my value to 3. Alright, I can decrease my value to 3. Now again I find a D here. Now when again I find a D here, I need to decrease from 3. So what are the options that are available here? Either 1 or 2. Again, both of these have been already used. So I cannot use 3 here. So if I do not want to use 3 here, I shouldn't use 4 here, right? That's the point because that's the reason we are using 3 here. So I do not want to use 3 here. That means I shouldn't place 4 here. I must look out for some other number. So let us assume I'm putting 5 there. Okay. If I'm putting 5 there, I'll just erase this. If let us assume I'm putting 5 there, then here it can be 4. And now again, here I can put 3. Alright. So I'll just write this properly. I'll be putting 3. Now 5, 4, 3, it's fine. Now again we have a decrease at this particular point. So what are the options now available for me to place? 1 or 2. Again 1 or 2 have been already taken place, already used. So I cannot use this particular thing 1 or 2 here. So if I do not want to use 1 or 2, I shouldn't use 3. If I do not want to use 3, I shouldn't use 4. If I do not want to use 4, I shouldn't use 5. So now let us remove that 5 as well. Now let us put 6 there. If I put 6 there, okay, if I put 6 there, what are the options? If I put 6 here, I can put 5 here, I can put 4 here, I can put 3 here. Perfectly pattern has been following, and also the uniqueness has been followed, and also this is the most minimum value possible. That is the reason 1 2 6 5 4 3 is the answer. Okay, from 1 to 2 there is an increase, from 2 to 6 there is an increase, from 6 to 5 there is a decrease, from 5 to 4 there is a decrease, from 4 to 3 there is a decrease. All right, so the pattern is being followed, and also the uniqueness is also being maintained. Also this is the minimum most value. All the three conditions are being followed. All right, so only funda that is there here is increase to a value, increase, okay, wherever you find an increase to that extent, okay, such that your decrease is compensated, increase in such a way that your decrease is compensated. All right, that is the thing. So initially you will be just increasing normally, like from 2 once I find I'll be putting 3 itself. Initially I'll be doing it, but once I encounter a D, all right, once I encounter a D, I'll be looking out for how many D's are there. By that much of D, I'll be increasing the value and I'll be replacing it. Initially I'll be putting 3, but once I see that I have found 3 D's here, so I'll be increasing 3 to 3, that is 6, and I'll replace this 3 initially that I've placed with 6. Alright, so that is how I'll be doing. And for the next of the things, till D is there, I'll be putting 6, 5, 4 and 3 because there are 3 D's, so I need to decrease. Alright, 3 D's need to be satisfied. Alright, so initially you will be putting at the normal initialization value only. From 2, what is the other value that's just increasing? 3. I'll be putting it 3 initially, and now afterwards if I find a D, and I'll be counting number of D's that are there to the right of it, by that much amount I'll increase the current value and I'll replace that current value. Alright, that is the logic here. So now let us go through the code, and even we'll try it on an example. So this is the code. Initially we have taken the n s0 len, and current number is 1 because they have asked us to do the minimum, give the minimum most value. So let us start with 1 and I equal to 0. So answer dot pushback of 1. So if my particular value is D, so I'll be initializing j with I, and I'll be counting the number of D's. Okay, this while loop is to count number of D's. Count D's. Alright, once I got the number of D's, like that is j minus I, because j minus I gives you the number of D's that are there, and I'll be increasing my current value with that number of D. See, like in the previous example we have I, D, right? So initially we had 1, 2, 3, and now we are replacing this with 6. Reason being, there are 3 D's, so 3 plus 3 is actually equal to 6. That is what we'll be replacing here. Okay, so answer of I would be, so that correct position I we are not updating, we are still at the position where we have found D, so there we'll be replacing that 3 by 6. That is what we have done, and int count is equal to current, so that tells me how many D's are there, how many things are left to decrease. From 6 I need to come to that point, where I'll be compensating all the D's. Alright, so that is what I'm doing. So while I not equal to j, so let the j would have been here, I would have been here, I need to traverse through all these 3 D's, and push back the count plus 0. I'm decreasing the count. Initially count is 6, right? Count is 6. What am I taking? Count is the current value, current maximum value, that is 6. And once for every iteration I'll be decreasing from 5, from 4, 3, because we have 3 Ds. All right, we have 3 Ds, right? We have 3 Ds, 1, 2, 3. So from 6 I'll be coming to 3. So that is what I'm pushing back. So answer dot pushback of say initially we have the most value 6, and then I'll be decreasing, and then I'll be pushing back again decreasing, I'll be pushing back again decreasing, I'll be pushing back again. So 6, 5, 4, 3 are the values that I'll be pushing. And if it is not, if it's just the I increasing thing, if it's just an like if S of I is actually equal to I, then in that case I'll just increase my value. So in this case, for example, if you're at this particular point from 2, you'll just increase that value to 3 and you'll push back it. All right, so you'll be making sure the value that you are increasing is the most maximum value among all the digits that you have covered. So we'll even do a dry run for your better understanding. Okay, I'll just delete these things. Okay, so just give me a moment. With this dry run, I hope you people will understand. So let us take this particular example: D I D D I D. All right, so this is the example, and these are the blanks that we need to fill. All right, these are the blanks that we need to fill. Initially my answer is actually equal to 1. All right, so I'll be putting 1 here, but I see I have a D here. All right, I have a D here, so I cannot put 1 here. I cannot put 1 because from 1 I cannot go to 0, so I need to replace 1. So what I'll be doing is I'll be replacing it with 2. I'll just use the white ink as white ink itself. So my value would be 2, and now here the value would be 1. All right, now here the value would be 1. Now I find again I here, so I can just increase it. If I just increase it, so I'll be having 2 here, but I cannot put it 2 because 2 have been already used. So what I'll be doing is I'll be increasing it to 3. All right, I'll be increasing it to 3. So now I find a D here. All right, now I find a D here. As I found a D here, I cannot have a 3 in this particular thing. Okay, I cannot have 3 because if I need to decrease, I'll be using 2, and because I've already used 2, I cannot do this. So I'll be increasing 3. Okay, I'll be replacing 3. I'll be replacing 3 with such a number so that it can compensate this D and this D as well. So there are 2 Ds. So what could be the answer? So 3 plus 2, original value that could be here, plus number of decreases, that is 2, totally 5. So 5 is what I'll be placing, and now I'll be decreasing 4 and then 3. All right, DD, so decrease from 4 and 3. Now we have an increase here. All right, now we have an increase here. So how we will be doing? Can you replace 3 with can you put 4 here? Can you put 4 here? No, I cannot put because 4 have been already taken place. So how can you increase? What would be the value that you'll be keeping? The maximum most value that you have seen till now, 5. So add that 1 to it. So that is 6 here. That's what we are doing. So current plus. So whatever the maximum value that you have seen, current would always be the maximum that you have found till that point, maximum digit. So just add 1 to it and push back that particular thing. All right. So that's what we are doing in this particular case. Now once we found a I, we'll be adding 1 to the maximum number that we have found, and that will be putting at this particular point. And now I see a D again. All right, now I see a D again. So I cannot put 5 here because 5 has been already been used. So what should be the number of increase? So initially we have taken 6, but we have seen there's a 1 D. There's 1 D to the right of it. So I'll be adding 1 to it. So that is 7. All right, so that's the reason I'll be replacing this 6 with 7, and I'll be putting 6 here. So the answer is 2, 1, 5, 4, 3, 7, 6. That is the answer. All right, so I hope you people understood what are we doing. So we are trying to count if a particular I is D, then we are trying to count the number of D's that are there totally, and that we are adding to the present value that we have actually thought of putting. So I have thought of putting 3 here. Initially I've thought of putting 3 here, but I see there are 2 D's to my right. 2 D's are there to my right. So I'll be adding 3 to 2. So that I'll be getting 5, so that I can compensate for both of these decreases. That is my main ideology. I need to compensate to the D's that are there to my right. So that is the reason I've replaced 3 with 5. And now once I've come to an increase, I'll be increasing that. I'll be putting a value such that that is the maximum among all the values that I've found, because I've used 2, I've used 1. I'll be putting in ascending order. I've used 1, I've used 2, I've used 3, I've used 4, I've used 5. Now what's the maximum value that I can put now? Only 6. So that is the reason I'll be adding 1 to the current value or the maximum value that I've found, and I'll be putting it there. Again I found a D. I need to compensate for it. So that's the reason I have found 1 D. So originally I thought of putting 6, but I found 1 D. So I'll be adding 1 to 6. So that is 7. So if I put a 7 here, I can do 1 decrease, I can have 6. So again, everything, all the unique values are being used. None of them are being repeated. All right, so that is the main logic here. I hope you people understood this particular code. So this is when you find a D, and this is when you find a I. So you're replacing, this is the replacement. Okay, this is the replacement, this particular statement, this is the replacement. All right, this is the replacement of ith initial value. Okay, initial value, ith initial, you have thought of putting some value, but you will be replacing it because you have found some D's to the right, so you are replacing it. That is what we are doing, answer of I. And this is like pushing back. So once you found some D, so here we have putting that's a 5 that we have found, and there are 2 D's. So what are the values that would be there? 5 to 4 there is a decrease, from 4 to 3 there is a decrease. That is what we are doing. From 5 we are pushing back 4, and then we are pushing back 3. Always we are doing count minus minus, and also we are pushing from we are going from I to J. All right, so J is the point where D's have ended, so we need to go from, we need to push our I till this particular point. All right, so in that case we are actually moving we are doing a O of n iteration itself. In O of 1 we are trying to solve this instead of doing O of n square. So I hope you people understood, and this is the I code. Also once you find some I, just increase the current plus like the current value that you have found till now, the maximum value, plus and push back to it, and also move the I pointer as well, because you are pushing back, you need to push the I pointer also, right? Because once you push it, so like let us assume this is the string I have. Now I've added some string, so now this must be the I pointer, this must be the I pointer. Now if I see that there are any D's to here, then I'll be replacing this particular value with number of D's, so that it compensates the compensates for D. All right, so this is the code, and you can, I'll even try to submit it for your reference. There is some internet issues, not to worry. So it will definitely work. I have already tried, and for your reference, codes in Java, Python have been given. Please go through them, and if there are any doubts, please let me know through the comment section. Thank you for watching. Stay tuned.